Welcome to my class 12 physics chapter, that is alternating current, and today we will discuss about your mean value of alternating current for half cycle, not for full cycle. Clear? We draw the graph for half cycle. Suppose this one is your current axis or y axis, and this one is your x axis, or that is also known as the time axis. We take time along the x axis and current along the y axis, and this point is the maximum value. In the positive side we write that is plus I0, and suppose this is the maximum value, in the negative side we write that is minus I0. Clear? And this line for the maximum value, and this line for the maximum value in the negative side. And this is the initial point, that is 0, and suppose this is the half of the time. Half of the time we write t by 2, and this point is the time period, we write capital T. Up to this is full cycle. Up to this is the half cycle, and this point is the maximum value, so that here we write time is equal to t by 4, and you draw the graph, reach at the maximum value, again 0. This is for half cycle, and here magnitude of the current is gradually increased, reached at the maximum value, that is I0. Again magnitude of the current is gradually decreased. That means magnitude of alternating current is not constant always. That vary with time, that changes with time. Only for this we will calculate its mean value or average value. Here magnitude of the alternating current is not fixed, that is not constant, so that we will calculate its mean value or average value, and only for half cycle. Clear? Suppose we take a small time, very small time, we take very small time, and for this small time we write, suppose that is dt. We write suppose that is dt, and in very small time dt, what is the charge? Charge flowing through the circuit, we write here, suppose alternating current is flowing through the circuit, and time given that is very small, that is dt. In dt time, you know the equation for instantaneous current, that is I is equal to dq by dt. This is the equation of instantaneous current. You know this in the chapter current electricity, and from this equation we write dq is equal to I multiplied by dt. That implies dq is equal to, here I, here this I is known as the instantaneous alternating current, and you know the equation of the alternating current, that is in place of I we write that is I0 sin omega t dt. This is the expression. This is the expression for current flowing through a circuit for very small time dt, if alternating current is there. If we give t by 2 time, because for a half cycle time is t by 2, that is the half of the time period. For t by 2 time, what is the net charge flowing through the circuit? We write here charge flowing through the circuit for time half of the time period, or that is t by 2. is, we write that is q. Q is the supposed net charge, that is integration of dq, or we write q is equal to integration, in place of dq we put this equation, that is I0 sin omega t dt. Time is from 0 to t by 2 because for a half cycle, and this is the total charge flowing through the circuit. This is the total charge flowing through the circuit when alternating current is there, and for half cycle, clear? Suppose in place of alternating current, suppose direct current is there. If direct current is there and the time given to the direct current that is same as the alternating current, that is also t by 2, then in time t by 2, net charge flowing through the circuit, we write for a direct current, total charge flowing through the circuit, suppose q is equal to, you know the equation, that is current multiplied by time, and your time is equal to t by 2. This is the total charge flowing through the circuit when a direct current is there. This is for a direct current, for a t by 2 time, clear? Then what is the mean value? What is the mean value of AC for half cycle? Here time given to the alternating current, that is t by 2. Here also time given for the direct current, that is t by 2. That means time given both alternating current and direct current, that is same, that is t by 2. And if charge flowing for alternating current, that is q, charge flowing for direct current, that is also q. If charge flowing through the circuit same for both alternating current and direct current, then this direct current is known as the mean value of alternating current. Clear? One second. Suppose charge flowing through the circuit for alternating current, that is q, charge flowing through the circuit for the direct current, that is q, that means both are same, and time given for a direct current, that is t by 2, and for alternating current, that is also t by 2, because here t by 2, this is t by 2, then the direct current is known as the mean value. So that in place of the I, we write that is mean value. Then from these two equations, we write I mean multiplied by t by 2 is equal to this equation, integration from 0 to t by 2, I0 sin omega t dt, and from this equation we will calculate the mean value. That implies we write I mean is equal to, we take I0 to the outside of the integration and we take t by 2 to the right hand side, so that this is divided by t by 2, integration from 0 to t by 2, remaining is equal to this amount, that is sin omega t dt. And you know the integration of sin theta, that is integration of sin theta d theta is equal to minus of cos theta. So that if we solve this equation, we write mean value is equal to I0 divided by t by 2, integration of sin omega t, that is minus of cos, in place of theta, here omega t is there, so that we write cos omega t divided by, here omega and extra term is there, that is omega, so that we divided by omega. This is the integration of sin omega t dt, lower limit is 0 and its upper limit is equal to t by 2. That implies we write I mean is equal to, we take omega out of the bracket, so that is minus I0 divided by omega multiplied by, here t by 2 is there, inside the bracket remaining is equal to cos omega t 0 to t by 2. Here omega is known as the angular velocity, you know that, and you know the expression for angular velocity, that is angular displacement divided by time. And for one complete cycle, angular displacement, that is twice pi, and time taken, that is known as the time period t. So that for one cycle, in place of theta we write 2 pi, in place of small t we write capital T. So that in place of omega we write 2 pi by t. That implies mean value of SC is equal to minus I0 divided by, in place of omega we put twice pi by t multiplied by t by 2, here cos, in place of omega we write 2 pi by t multiplied by, in place of small t first we put the upper limit, that is t by 2, minus cos, in place of omega we put 2 pi by t multiplied by, in place of t we put the lower limit, that is 0. That implies I mean or average value is equal to minus t cancel, 2 cancel, remaining is equal to I0 by pi, and inside the bracket t cancel, 2 cancel, only remaining is equal to cos pi, and you know cos pi, that is minus 1. So that in place of cos pi we write minus 1 minus, this is 2 pi by t multiplied by 0, that is 0, and you know the value of cos 0, that is 1. So that in place of cos 0 we write 1. Finally we get mean value or average value is equal to, this is minus 1 minus 2, this is again minus, so that is twice by pi multiplied by I0. This is the twice by pi multiplied by I0 and 2 by pi, that is equal to, we write finally I mean, or that is also known as average value for half cycle is equal to 2 by pi. In place of 2 by pi we write 0.637 times of I0, and this is the final expression. This is the final expression of a mean value for half cycle. This is for half cycle, and this is also relation between, mean value and here I0, that is the peak value. Peak value of SE, that means for half cycle we get mean value is equal to 0.637 times of a peak value. Mean value is equal to 0.637 times of a peak value, and look at the graph. This point is the maximum. Suppose from this point to this point, suppose this is 1, then this is the middle point, that is 0.5, this is 0.5, then this is 0.6, then this is 0.637, clear? So that we draw the line. Then this current we write that is I mean. This is the peak value I0, that is the peak value, this is the peak value, and this is the mean value. Clear? And this is all about your mean value of AC for half cycle, or a relation between mean value of AC and peak value for half cycle. And in the next class we will discuss about RMS value of AC, or that is known as root mean square value of AC for full cycle. And thank you.